All right, let's take a look at a thermochemistry problem. So for this problem, we're going to use that one thermochemical equation, Q equals MCAT. That's kind of a cute way to memorize it. So yes, I know this is not the letter A. That is a triangle there representing the symbol delta, which means change in. But that's just a cute way my kids taught me how to memorize it. So Q equals MCAT. Here we go. It says how much heat. Right there, I know I'm solving for Q. How much heat is lost? That means it's going to be an exothermic process, and Q will have a negative value. When a 780 gram piece, that I can label as my mass, piece of copper, it's going to cool down. So I've got two temperatures here. It looks like it's starting at a really high temperature and ending at a much lower temperature. So I'm going to label this as my initial temperature, T sub I, and I'm going to label this as my final temperature, T sub F. And then it goes on to give me just a nice specific heat of copper, and I can throw that in the equation for C. Just in case you forgot, Q represents heat, M represents mass, C represents specific heat, and delta T represents change in temperature. So when I read the problem, I'm probably going to get all three of them, and then one's going to be missing. And in this case, I'm missing Q. That's going to be my unknown. So let's go ahead and plug in here. So Q is unknown. I have a value for mass. I can plug in 780 grams for my mass. My specific heat, they give me in the problem, 0.38452, and that's joules divided by grams times Celsius. I know that has funky units. I'll show you how they cancel in just a minute. And then for temperature, here we go, delta T. I'm going to write down below it how I kind of solved for it. To solve for delta T, it should be your final minus initial temperature, so T sub F minus T sub I. So my final temperature, once this piece of copper cools off, looks like it was 33 degrees Celsius. My initial temperature looks like it was, 475 degrees Celsius. So when you subtract this, yes, you do actually end up with a negative value for temperature, which is fine. I know that upsets some students. You can have a negative change in temperature. All that means is that your Q value will end up being negative, which has a significance. That means that your process or your reaction was exothermic and it was releasing heat into the environment. So I look like I'm all set here. Punch in your calculator 780 times 0.38452 times negative 442 degrees Celsius. And you should get a rather large value for Q, which sometimes scares some of my students, but that's okay. Your grams are going to cancel here, your Celsius will cancel here, and your unit that you are left with for Q is going to be joules, which makes sense. Our unit for heat is usually going to be joules or calories. In this case, we are using joules. So your final answer should be a negative 132,567.1, and my unit here is joules. So that is my final answer here. You could have also kept it a positive and said this much heat will be released into the environment. So there are a couple of tricky things here. That key word up there in the problem says how much heat is lost, meaning released into the surroundings. So you can either represent that with a negative Q value, meaning exothermic, or you can just write, this much heat was, lost or sent into the surroundings. This has been a Rodriguez original production. I hope this helped. Go back, study your notes, look at more examples. Good luck.